So what does it mean when we talk about classification of remote sensing imagery? Well, these are all the sorts of interpretations that we can do with remote sensing imagery: classification, enumeration, measurement, and delineation. And you can see that one of the unique things about classification is that we try to assign some value to every area in the image instead of just maybe tracing out one particular area or counting features within the image. So one of the goals is to get these different classes or categories assigned to all of the pixels in the image in general. So how do we do that? Well, we want to assign a category to each pixel, and we want this to be based on the brightness value or the digital number that's associated with each pixel measured at a specific band. So we're going to use either one band or multiple bands from the remote sensing image. Remember, those are measured in different parts of the electromagnetic spectrum. And then we're going to plot the brightness values of multiple bands for each of the pixels in that imagery. And then then we're going to try to cluster these. Once we've plotted them all, we say we're now in frequency space because we're seeing how often these different brightness values occur. And we're going to see where the natural clusters occur in our image. Then we're going to assign different classes or categories to the clusters. And of course, this is just our best guess of what it is. In order to verify this, we would need to go out and collect field data to see if what we thought was on the ground was actually on the ground. And we would have to do some sort of accuracy assessment to see how many of our pixels were correct. So, with remote sensing imagery, we typically have different bands, and each of these bands is recorded in a different part of the electromagnetic spectrum. So all four of these bands would be over the same area, and if we're looking at just one pixel there, all four of those pixels would be over the same point in that area, but they can all have different brightness values. This one has a brightness value of 23 in band 1, 42 in band 2, 89 in band 3, and 94 in band 4. And that's because they're measuring the brightness of different portions of the electromagnetic spectrum. This might be red, this might be green, this might be blue, this might be ultraviolet. So we want to somehow take those digital numbers or those brightness values. We want to look at how they combine, what sort of patterns they have if we look at one compared with another. And we want to assign some categories based on how they compare. And one example of this might be land use. What type of land use or land cover is in that area? And this might vary from things from agricultural to industrial to urban to rangeland to forest, etc. So how do we actually go about doing that? Let's start with the easiest case. If we're looking at just one band of the remote sensing image, we can break it into categories just by looking at the distribution of brightness values. Here we're not looking at the map, right? We're taking all of the brightness values off the map and we're making a histogram with it, which is what this is called. And then we're just putting a break in here demonstrated by this red line. So now everything on this side of the red line would be in category 1. Everything on this side of the red line would be in category 2. Where would those be on the maps? Well, it just depends on each pixel's brightness value, and we would have to be able to relate those two back and forth. So here's a simple example here. Here would be the numerical values, and you can see here they're just varying from 0 to 9. And here would be the two categories we're breaking this down into. So if we look at that previous slide, where is the red line on this map? Well, we can see that if we look at the patterns here, 1, 4, and 3 are included, but 5 is not included. This pixel here is not part of this white area. So B is actually 0, 1, 2, 3, and 4. And then 5 through 9 is assigned to category A. So we're basically just breaking this entire image into two different categories. This would be in category A because it's greater than, it's 5 or greater. And much of this area here is in category B because it's 4 or less than 4. And then we can just show what that pattern looks like on the map. So this would be an example of classification. We've discussed it before as level or density slicing. And that's exactly what we're doing here because we're only using one band of data.